So I am back in my PHPP, and let's get started modeling our fresh air ventilation system. So if you've been following along, hopefully you have a PHPP that looks roughly something like the one on the screen here. We are getting some results here when it comes to things like heating demand and cooling demand, although we should pretty well ignore them at this point. We haven't yet modeled enough of our building for those results to be actually relevant or even remotely correct. But at least it is working. We are getting some results there. But in order for us to sort of finish off the work that we need to do to calculate our heating energy demand and cooling energy demand, the last piece of the puzzle, as we've talked about, is our fresh air ventilation system. So let's go ahead and attack that here in this next series of videos. So I'm in the verification worksheet right now. And again, if you've been following along, you should be done up to the shading worksheet. So that was the last piece that we completed in our example PHPP model here. So what I'm going to do is I'm going to come to my PHPP and we're going to go to a whole new worksheet. And there are two worksheets that we're going to be interested in. So I'm going to come over here and scroll to the right a little bit. There are two different worksheets that we want to concern ourselves with. The first of them is right here, and it's the ventilation worksheet. So the ventilation worksheet is going to be the first worksheet that we will take a look at. Then there is also a summer ventilation worksheet. It would be easier if this one was named winter ventilation and this one was named summer ventilation, because that's kind of actually what they are, although it's not quite as clearly separated as that. But that would be a good way to think about them. Think about this as your wintertime ventilation worksheet, where you're going to enter all the information around the wintertime performance of the building, the flow rates for the wintertime. And then over here, we have our summer ventilation worksheet, which is where we're going to enter the summer flow rates and ventilation related items for our building. So two separate places where we need to enter some information. Notice also here, before we jump in, that there is a third ventilation worksheet here down on the bottom called additional vent. And the additional vent or additional ventilation worksheet is a more in-depth worksheet that allows us to model more complicated or model systems in more depth and more detail than the worksheets that we're going to look at here as part of this class. We'll take a look at the basic ventilation and the basic summer ventilation worksheets, but there is this additional ventilation worksheet if you do want to do a more in-depth room by room system delineation and description, or if you have more than one ERV or HRV. So as we get into more complex or larger systems, the additional ventilation is going to take the place of the typical ventilation worksheet. So the typical ventilation worksheet is useful as a starting point for small projects like the one we have here, but as soon as we get into larger projects, we're gonna skip over that one and go right to the additional ventilation worksheet. That's where we're gonna enter the more complex systems. But don't worry about that for now. We won't worry about that in this class. Maybe in the future we can come back and take a look at that one. For now, what I want to do is I want to go to this ventilation worksheet. So I'm going to come over here and I'm just going to click on ventilation worksheet, and there's a whole new worksheet we haven't seen before. So before we go any further, let's just zoom out a little bit, sort of take a look at what we have here. So let me come over and zoom out, and let's see what we've got. We've got our worksheet here kind of broken up into three different chunks. So we have an initial chunk up here, which has to do with the airtightness and the volume of the building, as we'll see when we get into it. So this upper chunk is going to be where we're going to enter stuff around the tested ACH of the building and the volume, etc. And then we have a lower chunk down here, a second chunk or section, which is where we're going to describe the fresh air ventilation system in wintertime, both in terms of the flow rates, as well as things like the ducting and the insulation on the ducting, etc., etc. So sort of two different sections here for us to concern ourselves with. So let's hold off on this lower one. Let's start by just looking at this upper section, the airtightness of the envelope and the volume of the building. So let me zoom in a bit here so we can see what's happening. So we have this upper section here, ventilation data, and remember in the PHPP, the only place that we're asked to input data are the yellow cells. So there's a lot happening here, but there's not really all that many places where we're asked to actually do anything. And some of them already have some data in them. So let's start from the top. First of all, we have our TFA. Well, that's just a reported value. We have our room height. Well, that's going to be a standard value for residences. So that is an 8.2 or 2.5 meter standard value for residences. And then we have our vented volume. Remember, we have to calculate this V sub V. That's just the TFA times 2.5 meters or 8.2 feet. In this case, it happens to be 11,000 cubic feet. Well, okay, so that's all done. We didn't have to do anything up there. The PHPP was smart enough to do all of this stuff already. Now, the first thing that we actually have to do on this worksheet is we have to describe to PHPP what type of ventilation system are we using. And so over here under ventilation type, we're going to be asked to select our vent type or ventilation system type from this list. So when it comes to Passive House buildings, the requirement for a Passive House certified building is that you provide adequate or appropriate fresh air ventilation, healthy and comfortable interior spaces, and that you meet the energy performance thresholds. There is no specific requirement when it comes to new construction typical certification that you have a specific type of ventilation system. If you're working in Los Angeles or Hawaii or some other really mild climate, it may be true that you can properly vent your building using an extract air system or window ventilation only. Absolutely. However, in a place like New York, that's going to be all but impossible for us to deliver high-quality interior environments, good indoor air quality in the wintertime in particular, in a climate like New York, without relying on something like an HRV or ERV equipment. So for a Passive House in a place like New York, it's almost always the case that we're going to choose a balanced Passive House ventilation with heat recovery. But again, if you're working in other climates, it could very well be the case that you do not that you don't have an HRV or ERV, and you might want to choose one of these other types as a result. For us in New York, though, we're going to go with a balanced ventilation with heat recovery, so we'll leave that set to number 1. Okay, so we've now set up our ventilation system, so a bunch of other stuff in the PHPP is sort of turned on when we select that option there. And let's take a look at the next section. So the next section here, when it comes to infiltration air change rate, asks us for a whole bunch of information, and it also shows us kind of a funny table here. Well, let's skip over the table for a second. So let's skip over this table for a second, and let's go down to the first row where we're asked to input some information. All right, so what we're asked to input here is a wind protection coefficient labeled as E. So in the PHPP, they use the notation E to refer to this wind protection coefficient. And over here on the right-hand side, notice that we are asked to input a value. Notice also that it is a drop-down list, and so we're just asked to select the right value from this list. Well, okay, well, what value am I supposed to be using? What is the correct value for me to use for this? Well, this is where this table comes into play. The table here tells us how to select the correct coefficients from this list or this section on the right-hand side. So up here we have our E coefficients, and down here we have our F coefficients. Notice that we have a section here for coefficient F down below as well. So we have F and E. And so we have a couple different conditions that we have to sort of decide on. So first of all, is our building exposed on several sides, or is it exposed only on one side? I don't really know what a one-side exposed building would be. Is that like a hobbit hole or something? I don't know. Maybe like maybe it's an apartment in an otherwise sort of, I don't know, normal building, if you're doing like a single apartment or something. I'm not sure. One side exposed. I'm going to say that this is not us. So I'm going to sort of get rid of these. I'm going to say this is not us. So let's ignore one side exposed and let's focus only on several sides exposed, right? We're a freestanding building out in the middle of a field someplace, so we are definitely several sides exposed. So when it comes to the wind exposure of our building, we are exposed on multiple sides. So we're going to focus on column N here, right? This is going to be the column that we're going to be concerned with. And then what we have to do is we have to say, well, listen, is it a Is it a no protection situation, a moderate protection situation, or a high protection situation? And if you want, you can sort of hover your mouse over the element there. If it has that little red triangle, means there's a tooltip, and you can see that the PHPP says, well, a no protection, that's like a building in just like a wide open area, or some sort of like skyscraper that like sticks up above the rest of its context. Moderate protection is a building in a rural area with lots of trees, or sort of suburban development with other buildings around it that are going to block the wind exposure of the building. And then a highly protected building would be one that is really sort of ensconced in heavy tree cover or other buildings around it. A townhouse that's like nestled inside of other buildings on all sides, that kind of thing. Well, for our building, we're building a single family home out in the middle of a potato field someplace. So I'm going to say that we're no protection. So I'm going to say that we are going to be this row right here. So in order to select the correct wind coefficient E, all I'm going to do is come over here to the right, and I'm going to locate this number, and it says 0.1. So down here, I'm just going to choose 0.1 off the list. And notice the PHPP is going to do some stuff in the background. All right, so this will be us right here. So this will be the one that we're going to choose. We're going to choose this guy right here. That'll be us. The others we don't have to worry about. And then for coefficient F, it's even easier. Coefficient F, we just have a single value. So we're just going to use 15. Right, we're in this column right here. So coefficient E and F are now done. There's nothing else we have to do there. We're just going to choose the right value off the list. If I wanted to, of course, I can always come in and I could type in some other number. If I felt like 0.1 was not, well, you'd have to do a little monkeying around. But we could go in and override that, type in another number if we wanted to there. It's just a reduction factor. Some number between 0 and 1. In this case, 10%. Okay, so that's good there. So those are done. The next thing that we need to input here in our ventilation section has to do with the air change rate at 50 pascals of pressure. So row 27 here is asking us to input the tested ACH at 50 pascals of pressure. So this is your blower door test result. And for pass-fail certification to the new construction target, remember we have a maximum N50 of 0.6. For low energy building, we have a maximum N50 of 1.0. And for EnerFit, energy retrofit projects, we have a maximum ACH or N50 of 1.0 as well. So those are your maximums, though. In practice, you're going to get something like a 0.97 or a 0.86 or a 0.34, whatever number you're actually going to get in the field when you build your building. Which, of course, begs the question, well, what am I supposed to put in here? I mean, I haven't built the building yet. That's the whole point of doing the PHPP, is I'm trying to model the performance of the building before I ever build the building so that I can make good decisions about how to deploy different strategies on the building. So I can't exactly wait till the building's all done and then model and then input the number. That doesn't really help me at all. So what do I put in here? Well, you can put whatever you want. You could put 0.000001. And now what you've done is you've said to your build team, guys, we need to build a space shuttle. I would not recommend that. You'll get some pretty good results on your PHPP. Your model would show very impressive heating and cooling energy performance. It would not really have much bearing on reality, because, of course, in reality, you are not going to achieve 0.00000001 ACH at 50. My recommendation to you, and this is just a recommendation, this is not a rule. My recommendation to you is to put in the largest value which would still result in certification. So while it is true that you can put in whatever number you want, I would recommend, and this is what we do in our firm, we put in the largest number that would still result in a successful certification. So for new construction, that's going to be 0.6. For a renovation or a low energy building, that's going to be 1.0. So depending on the certification that you're targeting, you could input whatever number you wanted, but again, I recommend using the largest number that would still succeed in achieving certification. So I would say that for a new construction, we would put in 0.6. And again, if it's low energy, or if it's a low energy building, or if it's an EnerPHit, you'd put in 1.0. Now, why do I say that? Well, I think that's the conservative approach. You don't want to assume that I don't think that you're going to do, 60% better than the passive house target. So I think what you want to assume is that you're just going to make those air tightness numbers. And then if you actually do better than that in practice, which I hope you will, well, good for you. Then you can come back and you can revise that number down, and you can use those energy savings to offset those aluminum windowsills that showed up on the job site unbeknownst and went in before anybody had a chance to take a look at them, because they weren't on any of the shop drawings and they weren't on any of the details, and they just sort of showed up on the job site. Those sorts of things happen on job sites all the time. And so you can use the energy savings there to sort of pay off some of those unexpected debts that occur during construction. So build yourself in a little contingency here by using the largest potential or allowable number. That's my recommendation. It's not the rule. I could come up here and I could put in 0.4, or I could put in 0.3. But now I've baked in a really aggressive number for my build team. And I've said to everybody, well, look, guys, you're going to have to just do even that much better than the normal passive house building. Because why? Because I couldn't figure out how to hit the heating energy demand in any other way. Well, I would not recommend doing that. I would recommend keeping it at the largest number that you can, and then again, kind of capture or utilize those savings later on if you do end up doing better. Now, of course, this is for design. When it comes to certification, at the very end of the project, you'll have to revisit all of this, and you'll have to update the PHPP to your as-built condition. And in that case, you're going to take your tested ACH report from your blower door technician, and you're going to enter the actual number. So you'd come back in here and you'd rewrite this, 0.432 or 532, whatever the number is, whatever number you get from your actual test. But that would only occur later on, right? We come back and we update the PHPP with the as-built information. But during design, we want to keep this fixed at that largest feasible allowable number that gets us our certification. Now, for our project here, we have to decide, are we targeting low energy building certification, or are we targeting new construction certification? Let's go back to our verification worksheet for a second. Let's see what we input. So let me go back to verification, and let's scroll down here. And over on the right-hand side, we are currently saying that we are going to try and get to the Passive House Plus Classic, or Passive House new Construction Plus certification. So for our purposes, the largest allowable heating or air tightness value is 0.6. So, okay. Fine. So that's what we're targeting for now. Maybe later on we want to come back and test out low energy building. I'm actually a big fan of low energy building, I have to admit. That's my preferred certification for these types of buildings, but that's okay. We can choose whatever we want for our building. You can choose whatever certification works best for you. So go back to our ventilation worksheet. All right, so we have just about done everything we need here when it comes to air tightness. There is one last value that we need to input, which is our VN50. Oops, our VN50. So we have to input the VN50 over here. But I think what we'll do is come back and do that in another video. We've already gone a little long in this one, so I think I'm going to cut off this video here. And then when we come back in the next session, we'll talk about this volume question, and we'll talk about how we're going to input the correct VN50. So I'll see you back in the next session, where we will take a look at that VN50 value and how we figure that out.